In this section, we are going to talk about another data structure known as a binary search tree. In order to get an understanding of what a binary search tree is, a BST, we need to understand that it has three properties. The first property is the left subtree of a node contains only nodes with lesser values than the node's key. The second property is very similar, except with it being the left subtree, it is going to be the right subtree, and instead of it being lesser values, it is going to be greater values. And then the third property is that the left and right subtree must also be a binary search tree. So some additional terminologies that we need to understand is a root node. It is the top level node. And then we have a leaf, which is a node with 0 children. So if we did a mock tree real quick, this would be our root node. This would be our left leaf, our right leaf. Now we have another left leaf. This is no longer a leaf because now we have children here. So this is now a subtree. And this is a leaf, leaf, and this is still a leaf. So now let's look at some values and see how we can insert them. Because when you want to insert these values, there's a certain way that we need to think about it in order to ensure that our order is done the correct way. So what we want to do is we want to insert the values 8, 3, 10, 1, 6, 14, 4, 7, and 13. So let's bring this down. So the first value we want to insert is 8. So 8 is our root node. And when we insert values, we always start at the root node and then traverse accordingly. So now we're going to insert the value 3. So with 8 being our root node, 3 is less than 8. That means we go to the left and we add our 3. Similar with 10. 10 is greater than 8, so we will add it to the right. So now 3 and 10 are leaf nodes since they have 0 children. So now we go with 1. 1 is less than 8, so go to the left. 1 is less than 3, so go to the left again. Now we have 6. 6 is less than 8. 3 is less than 6, so 6 is greater than 3, so now we have 6 here. 14. 14 is greater than 8. 14 is greater than 10. 4 is less than 8. 4 is greater than 3. 4 is less than 6. 7. 7 is less than 8. 7 is greater than 3. 7 is greater than 6. And finally, 13. 13 is greater than 8, which is greater than 10, which is less than 14. So this is what our final tree would look like. So in here we have a leaf, 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 and leaf, and then all of these. So 3 subtree is 1 and 6. 6 is a subtree here. We have our subtrees here. So this is what it looks like when you try to insert values into a binary search tree. So overall, the concept is pretty simple to understand. So now that we have a good understanding of what a binary search tree is, we can begin implementing one. And we will begin implementing our binary search tree in the next lecture.